Okay, so first let me discuss that homework question. I don't know where that question is there. Just a minute, I'll check. This question, right? Okay, I'll discuss now. Very simple question only this is. Just if you understand that basic properties of logarithms, then you can solve easily. See friends. So whenever if you see these kind of things now, like if you see here, 2 is common. I mean 2, 3, 4, 5, 3, 4, 5. So the best thing is try to take some common base. So if I take common base here, what will happen? So this I can write it as, so see the solution. This any common base you can take, no problem. Let's say log 3. Some b I will take. I don't any base positive number you can take, no problem. Divided by, this is again log 2 base b. Okay. Into, now see here friends, log 4 base b, okay, divided by log 3 base b into log 5 base b divided by log 4 base b. So like that, into it will become log of n plus 1. Okay, so base b divided by log n base b, which is equal to 10, which they have already given. Now you can cancel, right? This, so this you can cancel. This you can cancel. So next here log 5 base b will come. So this one you can cancel. Like that, if you go, this one and this one will be cancelled. Okay. Now you are finally left with this term. So you are finally left with this term and this term. Okay. So which is equal to log n plus 1 base b divided by log 2 base b. Now I can remove base, right? Because I only write common base. So I can remove, no problem. Then it will become log of n plus 1 base 2, which is equal to 10. Okay, I should not write here. So this is equal to 10. So this is equal to 10. So this one I can write it as log n plus 1 base 2, which is equal to 10, friends. Okay. Now it is very simple. By writing what number here, I will get 10 here. Can I write 2 power 10, right? Simple, na? See, by writing what number here, I will getting the value 10. So log 2. So if you write 2 power 10, so from the properties of logarithm, this 10 will be coming here. Okay. So which is going to become 10 into 1. And you are going to get the value 10. Yeah, that is true. Correct. So therefore, this n plus 1 is going to become 2 power 10. Correct. So from this, n plus 1 is going to become 2 power 10. So 2 power 10 is 1024. So from this, n is equal to 1024 minus 1. So which is 1023. Simple. I think this is previous some JEE question. IIT JEE question this is. Okay. So everyone understood, friends? It's clear? Okay. Somebody saying he solved it also. Very good. Very good. So just a minute, I'll decrease the brightness. Okay. Now, so everyone take pen and paper, pen and notebook, everyone. So because today's class is going to be a lot of, as I said, it is a lot of knowledgeable. I'm going to take as many as examples that are possible. Okay. Everyone take your notebook and pen. Okay, now? Take it. So first, let me quickly take the summary of the last class. I mean, that is the first class on time and space complexity. That summary I'll see. Then I will take the next class, continue with the class. That is, so first we have seen the properties of the logarithms, right? So this table I have explained properties about logarithms. After that, so these are all the properties. I'm not going to explain any, so you please read it. Next, friends, I have talked something called as big O. But this proper definition, I haven't yet explained this proper definition, but I have told something called as big O will be there, order of. Okay. This function, this mathematical function plus, if you take big O, okay, then we can say that, yes, it is time complexity of some program. This is time complexity of, TC means time complexity of some program. Okay. some program. Okay, so what is these functions? These are the popular functions. See, many functions are there, but these are the popular functions, friends. Constant, logarithm, root n, okay, n log n, n square, n cube, 2 power n, n factorial. So these are the different functions. These function, if I included with the big O, then this is going to become some problem time complexity, some program time complexity. If I add big O to this, so it is going to become order of n square. So now this is time complexity of some program. Okay, now today's class, I will take all these examples. So I will take different problems where, okay, every one problem will take any one of these time complexities that I'll explain, friends. Okay, now like where this will come, order of one, where it will come. Simple, like if you have a statements like print statement. So if you have a statements like print statement, or maybe if statement, okay, or maybe else statement, else, or maybe break, continue, break, okay, next, continue. So all these constant operations, friends, these all are constant operations. So which is going to take time complexity as order of one. Simple. Okay, whenever if you see print statement or something just in one line, so they are going to take order of one, not inbuilt functions. Please take care. Inbuilt functions also just in single line, but their time complexity is not order of one. Just for example, in some programming language, if you want to sort the array, let's say we can write arr dot array name dot sort, we can write arr dot sort, we can write. Even though it is one line, but it's a time complexity as not order of one. Please take care. So is this clear, friends? Yeah, even though if it is taking one line, okay, but it doesn't mean that it's time complexity order of one. This is wrong. Okay, so what is its time complexity, that we will see. Okay, n log n, something like, depends on the sorting algorithm to algorithm, it will vary. Okay, good. Now, next we have seen something called, okay, when your function is like this, f of f1 is some function which is combination of n square plus n log n plus n. Can you tell me, friends, what is its big O? What is the big O here? Whichever is maximum, that you need to put it here. Whichever is maximum, that you need to put it here. Now among n square, n log n, which is bigger? Obviously n square is bigger. This yesterday I have explained also, I mean last class. When you have more than one functions, how to compare. Okay, good. Now next, this function. This function is combination of three things: n plus n log n plus n log n plus n log n. Which is bigger? See, please don't do the mistake. n into log n, n log n. Which is bigger? Assume n is very large. N is very large. N is very large. I think you people are not thinking. You're everyone typing n only. N is very large. N is very large. Is n bigger? N log n bigger? N log n bigger? Think again and tell me. You are not thinking. Let me take, this is first one, second one, third one. Which is bigger? Think again and tell me. People who are typing 2, see, if you have 2 logs, doesn't mean that this is bigger. Let me explain, friends. Okay, assume n is equal to some bigger number. I'm going to take, let's say n is equal to 2 power 10. Just I have taken a very large number. Any number you take, no problem. Okay, now n you already know. Can you tell me what is the answer of n into log n? N log n, I want to write it here. Assume everywhere, assume base 2. That's why I have taken 2 powers. Calculation will become simple. Okay, n is already you know, which is 2 power 10. Okay, into 2 into 2 power 10 into, if I apply log to this, what is its answer? 2 power 10, right? If I apply log to this. Okay, now if you compare this one, this, which is bigger? Let me take, this is 1 and this is 3. Among 1 comma 3, which is bigger? This is 2 power 1024. This is 2 power 1024 into 1024. Definitely 3 is bigger, right? If you compare this, 3 is bigger compared to 1. Everyone agree? Everyone agree with this point? This is just 2 power 1024 into 1 only. But this is 2 power 1024 into 2 power 20, which means compared to n and n log n will be bigger because you are multiplying with some term, right? Okay. Now let me take n into log n. This is interesting, friends. That is n into log n. Okay. First, let me take n into log n. N into log n. Okay. Now see what is its value. You know already n value, that is 2 power 10. This you know already because we only take let. Here you take let. Okay. Into, okay, log. What is the value of this log n, friends? You know already, that is already present here. 2 power 10. Okay. Which means once if you take a log, for that one more log you are trying to apply. In that case, what this value is going to become? This is 2 power 10, which means 2 power 1024 into 10 into 10. Now tell me, among 3 and 2, which is bigger? 3 is bigger or 2 is bigger? This is 2 power 10, 2 power 10 into 2 power 10. This is into 10 only. Definitely 3 is bigger. So got it now? I think what is the mistake that you are doing? If you have 2 logs, doesn't mean that this is bigger, friends. One time you apply log, for that one more time if you apply the log, that value will be decreases by a lot. Okay, na? So blindly don't say that 2 logs are there, therefore this is bigger. No, that is not correct. Okay, good. Now tell me, what is the answer for this finally, big O? Finally, what is big O for this? Yes, very good. That is 3, friends. Order of n into log n. Order of n into log n. Okay, good. Now, just to see this, if you have 2 functions, one is f of n plus another is g of n. If you want to write big O of these two, what you should take? Whichever is bigger, that you need to take, which means maximum of these two you need to take it, friends. Because you know, right? N square, n log n. There can be more than 2 is present. If here 3 functions are there, maybe this you can take f, this you can take g, this you can take h. Among these 3, finally, whichever is bigger, that you need to write it here. Okay, if you have only 2 functions, simple. In those 2 functions, whichever is the maximum or whichever is the bigger, that you need to write that. Hope this is clear. Okay. Yeah. So whenever if you have any doubts, please raise your hand. Okay. If you have any doubts now, please raise your hand. Okay. Now, so we will see a few points, then I will take this. Okay. So among F1 and F2, which is bigger? Okay. Good question. Can you help me, friends? Among F1 and F2, which is bigger? This is n square, which means n into n. Okay, good question. I'll try to compare F1 and F2. Okay, so F1 is n square. F1 is order of n square. F2 is order of n into log n. Okay, among F1 and F2, which is bigger? It is very easy. So n square, I can write it as n into n. N log n, you can write it as n into log n. So when you comparing 2 functions, you can cancel n and n. Okay, this is n and this is log n. Now yesterday's I already taught n power, how much big small value that is present, epsilon, will definitely bigger than log n power, very big value. Log n power, very big value. Very big value. Correct? Okay. So obviously this is bigger. F1 is bigger. Okay. Right? Sir, what should be the answer? Why not option 1 or 2 instead of option? No. Yeah, see, this is a different question. This is the first question. Okay. This is the second question. This is the first question. This is the second question, friends. Please don't combine these two. Both are different. Now somebody asking, sir, why not option 1 or 2? See, this is taking n along with n log n. N among these 3, which is bigger? That is the answer. You have to write it here. Okay, I'll give you a simple example. Let's say, okay, what should I say? Okay, let's say you 2 friends are there. Let's say you are there, friend 1. Okay, I'll take two names. Okay, so Sai is one friend, and okay, Ravi is another friend. Okay, now let's say Sai want to meet his girlfriend. So Sai want to meet his girlfriend. Okay, so but Sai didn't have any bike. Okay, now Ravi is having a bike, friends. Ravi is having a bike. Okay, Now listen carefully. Now Ravi is having a maybe Royal Enfield bike is there. Now Sai asked Ravi, please give your bike, I'll give in some time. Now, if you want to, Sai want to meet his girlfriend and come back to his home. So assume Sai is going to take, let's say 3 hours time. 3 hours time, for example. But so Sai girlfriend now busy with some other boyfriend. Okay. So let's say busy with some other boyfriend, Hari. Okay. Right. Now, when Sai called to his girlfriend, maybe you take name as Rani. So okay, when Sai called to Rani, so she told her, okay, you come back, we will meet and we'll do something like that. This Rani told. But the moment when Sai went to the middle, Sai somewhere went to the middle, Rani told that, "Are gar mein some parents are coming. No, please don't come. You go back." Then Sai is disappointed. But in the disappointed, Sai want to meet his another girlfriend. Okay, some Lakshmi. Okay. To meet this Lakshmi and to come back Sai, he is going to take, let's say, 2 hours of time. 2 hours of time. Now, to be on the safe side, Now, can you tell me, like, how much time should Sai has to say to Ravi, give me any one girlfriend, you go and meet. Any one girlfriend, she go and meet. Now, how much time should Sai ask to Ravi for the bike? How much time? Assume only one at any point of time on the day, either Sai can meet Rani or Sai can meet, okay, Lakshmi. Only one girlfriend he is going to meet. On the same day, it is not possible, friends. Okay, on the same day, either Sai can meet, okay, Rani or Sai can meet Lakshmi. So to be on the safe side, what Sai will think, for example, if Lakshmi gives hand, maybe I will go meet Rani and do something. Then whichever is bigger, that much time, obviously Sai is going to ask to Ravi, right? To be on the safe side. If he asks only 2 hours, for example, if let's say if Lakshmi gives a hand, then obviously he can't meet Rani, right? Then that day is gone. So to be on the safe side, whichever is maximum, that this I will ask. Similarly, okay, time complexity also. The maximum I want to tell. This is taking n time only. This is taking n log n only. Please don't add. What I told, on the day, either he can meet Lakshmi or he can meet Rani. Only one girl he can meet. Not both of them. Got it now. So therefore, obviously, which is bigger, that he will tell. I think, I don't know, is it good example or not, but I hope you understood the essence, right? So at the end, which is the maximum, that be on the safe side. Friends. Okay. Right. I'll take. Please wait. So I'll take those questions also. Okay, good. Next. Now, friends, first one I have already told. N power epsilon is always bigger than log n power very, very, very big value. You take k is as much as you want, but you take epsilon very small value. Still, n power epsilon is bigger. Okay, now can you help me among root n and log n? Okay, which is bigger? Can you help me? Obviously, root n is bigger. Okay. Root n is bigger. Okay, people who are having a doubt here, sir, why you have taken maximum? Just wait till the end of the class, you will get the clarity. Wait till the end of the class, you will get this clarity. Why I am taking maximum? Okay, because I have, see, so many examples I have kept here. Lot of examples for you I had kept. Okay, please don't disturb by asking some other questions. After answering these all questions, now lot of things will be clear. Please wait. Lot of very good examples I have kept here. Okay, like if you disturb in between, now obviously I can't finish all the questions, right? You are in loss because this is the last class on time complexity. So, okay, please don't disturb in between. If you have genuine questions, please ask. Okay, now see, friends, next I want to take one more topic, that is called increasing GP. So I'm going to take one series which is in the increasing. So let me take 1 plus 2 power 0, 2 power 1, 2 square, 2 cube plus 2 power n. Can you tell me, is it increasing GP or not? GP means geometric progression. Please don't ask what is GP, okay? Geometric progression. Okay. What is the formula of sum of n terms in the GP? Sum of n terms, what is the formula? So Sn is equal to A into R power n minus 1 divided by r minus 1. Correct? This is correct. Sum of the n terms in the GP. Now here, how many terms are there? N plus 1 terms are there, right? Here, if you see, first term, second term, third term, fourth term, and so on, n plus 1. So what? So here, a is equal to 1, first term. What about r value? T2 by T1, 2 by 1. So which is 2? Which is 2. Now, what about some formula here? Sum of n plus 1. So a into, in place of n, you are going to keep n plus 1 minus 1 divided by r minus 1. Because we are having n plus 1 terms, that's why I have written Sn plus 1. Now try to substitute in this formula. A value will be 1, okay. 2 power n plus 1, okay. So 2 power n plus 1 minus 1 divided by 2 minus 1. Okay, so which is equal to 2 power n plus 1 minus 1. Okay, so which is nothing but 2 into 2 power n, I can write it, yes. Okay, minus 1. Now, can you help me? If same thing, this expression, if I want to put in terms of big O, so can I write it as order of 2 power n? Because whichever is maximum constant, I can ignore. Can I write like this? Okay. So if you ask why you are not writing this 2, why you are not writing this minus 1, once you understand the definition, it will be clear. For time being, trust me, whichever is bigger and constant, we have to ignore. So two things I'm going to write it here. So when you are writing big O, like when you are writing big O, when you are writing big O, okay. So two things you need to take care, friends. Okay, ignore the constants. Ignore the constants. Second is, whichever is bigger, that needs to be kept inside big O. Inside big O, okay, which means here. That needs to be kept inside big O, okay. Just please remember these 2 points, because see, once I explain the proper definition of the big O, these things will be clear. Right now, you just believe that. Okay. How somebody saying how 2 into 2 power n came? Are this is 2 power n plus 1. This I can write it as 2 into 2 power n, right? It's properties. 2 into 2 power n. When bases are same, okay, this is nothing but 2 power n plus 1. That's why 2 into 2 power n minus 1. Okay, that's therefore this is order of n. So therefore this expression, whenever if you see this expression, you can blindly replace this expression with order of 2 power n. Clear now? Whenever if you see this expression, blindly you can replace this order of 2 power n. If it is a increasing GP, you take the last term and you put inside this big O. Okay, na? Very simple. Whenever you see increasing a GP, you take the last term and you put inside this big O. Simple. Similarly, we need to see decreasing GP also. Because see, these are going to help in the next problem, friends. That's why I'm saying. Please concentrate here. Next, let me take a decreasing GP. So which is decreasing GP is nothing but 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube and so on 1 by 2 power n. This is clear. Now I want to find out what is big O for this. Now my question is, what is big O of this? What is big O for this? Okay, right? Just to see this, friends, just to see this. Rather than taking n terms, so here we have total n terms, right? I will take infinite terms and I'll see what will happen. That is 1 plus 1 by 2 plus 1 by 3, sorry, 1 by 2 square plus 1 by 2 cube up to so on infinite. Okay, see, they are just asking for n terms only, but I want to find out for infinite terms. So what is the formula of infinite terms in the GP? What is the formula? S infinite, it is nothing but a by 1 minus r. Am I correct? Is it the formula? R minus 1 or 1 minus r, whatever it is, no problem. Okay, try to substitute in this formula. 1 divided by 1 minus 1 by 2. So I'm just substituting in this formula. So from this, A is equal to 1. Okay, R is equal to 1 by 2. Right? So 1 divided by 1 by 2. So 1 divided by 1 by 2, which is going to become 2. So if this is simple constant, so this one, can I write it as order of 1? Tell me, this constant only. Yeah, constants you can put inside big O of 1. No problem. See, the infinite terms itself is taking order of 1. Then these are the limited terms. So definitely these limited terms also I can take it as order of 1. This is clear. Simple common sense, right? The infinite terms itself is taking order of 1. In that infinite, this n is a small part. Then definitely this also, right? Definitely less than 1 only. So therefore, by constants, you can replace it as order of 1. I don't know everyone understood or not. I'll explain again, friends. The infinite terms itself is taking constant. Then these are only few terms only, because these are n terms. Infinite means so much is there. Then definitely this also you can write order of 1. Okay. So if it is a decreasing GP, then whatever is the first term that you can take and put it inside this big O. Simple. Okay, na? Clear? If it is a increasing GP, okay, then you take this term and you put it inside here. If it is a decreasing GP, you take first term and you put it here. See, friends, one thing, friends, whether it is 1, whether it is 10, whether it is 20, whether it is 100, okay, these all are constant numbers. Basically, these all are constant numbers. So these all constants, you can represent it in big O of 1, no problem. Okay, na? All these constants, 1, 20, and so on. These constant numbers, you can happily put inside this big O. For the time being, you need to accept these things, because I haven't explained the proper big O definition. If I explain the big O definition, you will leave the class, because it is boring. It is boring. I don't want to take boring things in the beginning. I want to take some interesting things in the beginning. That's why. Okay. Just wait for 10-15 minutes. After that, you will love the session. This will go in a like different level coming classes, because these all are the basics what I am teaching. Okay, the coming examples, now like it will be super interesting. Trust me. Okay. So if somebody asking, it means 1 n constant runs in order of 1. Yes, yes. If it is a constant, order of 1. True. Okay. Just one last expression, friends. Whenever if you see something like 1 plus 1 by 2, 1 by 3, 1 by 4, 1 by 5. This is of what series? Can anyone remembers? This is of what series? Yeah, I think for the first time when I saw, I also don't know. So this is order of log n, friends. This expansion is order of log n, you can write. It is not AP, it is not GP. If it has to be AP means, then this formula needs to be satisfied. T2 minus T1 is equal to T3 minus T2. So is it satisfying this formula? No. This is AP formula. If it has to satisfy GP formula means, it should satisfy T2 by T1 is equal to T3 by T2. T3 by T2. Is it satisfying this formula? No. No. So it is not AP, it is not GP, friends. It is log n expansion. So a lot of mathematics are involved to prove this, but let's not hurry about proof. Okay, so some lot of stuff involved in the proving this. So proof, you can refer Google. Okay, for just believe this 1 plus 1 by 2, 1 by 3, 1 by 4. Okay, so it is order of log n. So proof is not required, because we are not a mathematical people to prove all these things. Okay, in fact, no one will ask also in the interviews. Right, now we are ready to go. Now we are ready to go. Code, time complexity, code, time complexity, code and time complexity, code and time complexity. Okay, now it will be much more interesting, friends. Okay, right, now we'll go back. Okay, so what we have seen so far, one is, if it is a, first thing is n power small is very bigger than n power log n power large. This is the first point. Second point, if it is a increasing GP, take the last term and you put inside the big O. If it is a decreasing GP, you take the first term and you put inside that big O. Then If the series is like this, so its value is order of log n. So these 4 points you just remember. Okay. So do you want time to note it on your notebook, or shall I go? You need time to write it on your notebook, or shall I go? Because anyhow, I will give this PDF at the end. Na? So I'll go. Okay. Okay. Right. So this I'll come back later. Now let's see, friends. These are the templates. These are the templates that I have already explained in the last class. If you remember, what is the first template? See, always remember, friends. Okay. Before analyzing the time complexity of any code, 2 things you remember. Okay. First thing is, see approximately how many times loop is running. Loop is running. First thing is, exact value is not required. So exact value is not required. Just a minute. Exact value is not required. That is the first point. Second point is, very minute details also we need to consider. Very small details also. Very minute details, which means minute or small details also we need to take into consideration. We need to take into consideration. Please remember. Okay, don't leave out simple things also. Don't leave simple things also. Very minute details will create a lot of difference. Second, approximately you see how much time it is running. These 2 points remember, friends. These 2 points remember. Okay. Now, first template. Okay, so 4 templates I have given here. These we have seen in the last class also. Okay, now check this. For example, if in place of A, if you have 1, let's say in place of A, if you have 1, how many times this loop will be running? Approximately. In place of A, if you have 1, let's say, n times this loop is running. N times. Okay. In place of A, if you are having 2, then approximately how many times loop will run? N by 2, right? Very good. This loop is going to run n by 2 times. See the starting point, see the ending point, and see how much that they are trying to increment. Okay. If A is equal to 3, then how many times loop will run? Obviously n by 3 times. N by 3. So in general, if it is running A times, then can I write this as n by A times? N by A times? Yes. Okay. Now same thing. Okay. I have written in the reverse order, which means I am starting at n. Okay. And I am going till 0 or 1, whatever it is, but I am decrementing here. See, always take where is the starting point and where is the ending point. I am starting at n. Okay. Next time it is becoming n minus 1. After that it is becoming n minus 2. And so on. At 0 it is stopping. So how many times it is running? This also running n times. So this also running n times, friends. Okay. This also running n times. So if you see, this is, I can say it is increasing. It is increasing. Can I say this is decreasing? Yes, because you have taken n value, then n minus 1, n minus 2 up to 0. Both are in terms of number of times loop is running is same in both cases. Okay, na? Next is, okay, now try to see this. Now see this. In place of A, here, in place of A, if you are having, let's say 2, don't take 1 if it not meaning, friends. If you have 2, then it is log n base 2, right? Starting from 1, okay, going till n, but this time it is a multiplications. Remember, this is not increment or decrement, this is a multiplications. So if it is a multiplication, then this is log n base 2. What if A is equal to 3? So same, if A is equal to 3, then can I write this as log n base 3? Yes. Log n base 3. In general, it is log n base A. Okay. Log n base A in general. Okay. Now tell me how many times this loop is running? Okay. Starting at n. Okay. Now if you see, friends, this is starting at 1 and you are just multiplying 2. And if you are multiply by 2, it will become 4. You multiply by 2, it will become 8. And so on. You are going till 8. N. Whereas if you see this, so here what is happening? Multiplication is happening. 1 you are multiplying by 2. 2 you are multiplying by 2. 4 you are multiplying by 2. 8 you are multiplying by 2, like that. Whereas if you take this, here what is happening? Here you have taken n. Next time you are divided by 2, which means your n is becoming n by 2. Then n is becoming n by 4. And so on. Up to you are going till when? See, this is you are going from, let's say, maybe Delhi to Simla. This is coming Simla to Delhi. Whatever it is, whether you are going like this, whether you are coming like this, don't you think both times printf statement will execute same number of times? Correct, na? Whether you are going from A to B or A to B, when you are going, you are printing. Similarly, when you're coming B to A also, here you are printing. Same thing. Ultimately, what you need to check, how many times loop is running. That is important for us. For us, what is important? How many times loop is running? How many times loop is running? That is important, friends, ultimately. In this case also, it is running order of log n. Here also order of log n. Got it? Any doubts, anyone? Somebody saying, sir, how to decide a time complexity, log or not log? Simple. Whenever if you see something like multiplication, so its time is n, log n, sorry. Okay. Sir, doubt in template 2, template 4. This proof yesterday I have explained, right? This proof I have explained yesterday. Okay, maybe I cannot write A here. Let me write 2 so that it will be clear. Okay, this write 2. I'll write keep A only, A in general. Okay. Or else, in simple words, if I want to say, if anything is starting at 1, then next if it is becoming 2, then next it is becoming 4, next it is becoming 8, next it is becoming 16, and so on, n. So every time what you are doing, you are multiplying by 2. What is its time complexity? Simple, remember, order of log n base 2. Okay, now? Next, if you are starting at n, if it is becoming n by 2, next it is becoming n by 4, next it is becoming n by 8. Every time you are dividing by 2 and you are coming till 1. So here, there you have multiplied. So here you have divided by 2. Sorry, divided by 2, divided by 2. It is in the reverse way. Then also time complexity will be order of log n base 2. Why base 2? Since you are doing hangama 2, 2. If it is 3, 3, then it will become log n base 3. That is the point. Now it is clear? Right? Okay, good. Now we are ready to go, friends. Ready to attack the problems. Okay. First question. Now every question I will give you some time. You please take your rough notebook, try to solve and tell me the answer. First you try and you will fail. Then I will explain the solution. It will remember in your brain. Okay, now see. Every time, see, friends. Every time you see how many times loop is running. That is important for us. How many times loop is running? Loop is running. Okay. Carefully analyze. Analyze very carefully. Very carefully you need to analyze. This is important. Okay. Now tell me, what is the answer? You take time also, no problem. Analyze very carefully. Justify is equal to I into 2 doesn't mean that every time it is order of log n. That is wrong. If you are thinking like that, then that is the stupidity. Okay. Don't by heart. Understand what is happening. Okay. How many times loop is running? Is it running 2 power n times or only 2 times? Should be very careful, friends. Does it running 2 power n times? Check it. Yeah, very good. People who are saying n, it is correct answer. People who are saying n as the answer, that is correct. Okay, simple. See, what is the template that we had? The template that we had is, let's say, for I is equal to 1, I less than or equal to n, I is equal to I into 2. If the code is like this, maybe inside some order of one statement is there. Print, maybe some star. It can be anything, friends. Some order of one statement has to be present. That's it. Okay, now? If this is the code, can you tell me what is its time complexity? Starting at 1, every time you are multiply by 2 and you are going till n, which means this is nothing but log n, right? See, don't say order of n. I'll kill you. If you say order of n again, I'll kill you. Okay, you are starting at 1 and you are going till n. Every time you are multiply by 2. Then what is its time complexity? Order of log n. Correct? Same. Therefore, this code time complexity is order of log n. Okay. But does, if the value is n, then this is n is your order of log n is your answer. But what is the value that is present here? 2 power n, right? Therefore, how many times this loop is running? How many times this loop is running? Order of log base 2, whatever the value that is present, whatever the value that is present, that should present here. Okay. Similarly, whatever the value that is present here, that should be present here. Correct? This is 2 power n. Now try to simplify this. What it is going to become? This is, can I write this as n into log 2 base 2? I can write it as, yes, of course. So we know this value is going to become 1. So overall, what is its time complexity? Order of n is its time complexity. Okay. Simple, now. Okay, Avinash, can you please unmute and ask what is your doubt? Yeah, everyone, Avinash, you please unmute, because so that with the doubts only others also will know better.
Sir, but this code is acting like a GP, sir.
How it is acting like a GP?
Sir,
let me take.
first of all,
I'll take this to the next slide and I'll explain. You see, I value will be 1. Okay.
Okay, sir.
After that,
I value will be 1 to 2.
Okay. When I is equal to 1, let's say 1 star is printing here. Correct?
Okay.
Then what we want, how many times loop is running, we want. Next time, I value becomes 2. Okay.
Okay. Okay, sir.
Star is printing.
Okay.
Then I is equal to
4.
2 square.
Yes.
Star will be printing. Then
2 power 3.
Star is printing.
Yes, sir.
So far it running 4 times. Okay. 4 stars you are getting. Until how long this loop is running I value? Whenever I value will become 2 power n, this loop will start, right?
Yes.
Whenever if I value is equal to 2 power n, then also this loop will work, right?
Yes.
Next time, when you multiply by, what is going to happen? 2 power n plus 1, right?
Yes.
This time this condition is true or false?
False.
False. Which means loop will stop.
Yes.
Loop will stop. Okay. Now, how many times now can you tell me these stars are printed?
These stars are printed 2 power n plus 1 time.
Hey, see, try to count it. Okay. This is the first time. First time star. Second time star is printed. Third time star is printed. Fourth time star is printed. Like that, nth time star is printed. Not value is 2 power n, but stars printing is not 2 power n.
We need to consider the print statement.
Hey, okay. See. This is in Python. Don't think that. In Python, if you want to multiply, you have to write I is equal to, like this, you need to write, right? In Python.
No, sir, I'm not getting confused like that. I'm
Okay.
getting confused in 1, 2. It became a geometric progression. That's why I think
No,
in that manner.
like, here what I have told, na? Just like that, don't write. Analyze very carefully. Just like that, please don't write. Okay. Save. See here now. Now this is clear.
Yes, sir.
Okay. Maybe you take n is equal to, let's say, 3, for example. If you take n is equal to 3, this loop is going to run how many times? 2 power 3 times, right? 2 power 3, when this condition, this will fail, obviously. Okay. So 2 power 1, 2 power 2, 2 power 3. That's it. When it becomes 2 power 4, this loop will fail, which means if n is 3, 4 stars you are getting. No, so answer is finally order of n.
Okay, sir.
Okay. And one more thing that I want to say to everyone, this code treat like it's a normal pseudocode. This you please think like a pseudocode. Don't think like it is a Python code. As I told in the first class, language don't consider. Don't think as a Python code, please. Don't think as Python code, please. Okay. Python code, please. Okay, na? This is normal pseudocode. Pseudocode. Okay. Second question. This is interesting. See, take pen and paper. Otherwise, these things will not come, friends. What I have promised in my first class, without taking pen and paper, you will able to solve. But for practice, you need to take pen and paper. Okay, na? Once you do lot of questions with pen and paper, then your pen and paper is not required. Now, take pen and paper. See I is equal to 1. What is happening? I is equal. After that, what is happening? Try to see. Interesting part. Yes, very good. Very good, Kishan. One student. Very good, Kunal. Love you, love you. Everyone is giving correct answers. I think you people are thinking, taking pen and paper and you're solving. Very good, Roshan. Come on, others also. Take pen and paper, see what is happening. Otherwise, you can't get it. Take pen and paper, friends. So how many times this printf statement is executing? Yes, only one time. Only one time. Okay, don't by heart. If you by heart it, I mean, that is not right. Okay, I is starting at 1, I is going till n, which means it is order of n, then which means that is wrong. See what is happening here. See what is happening. I is incremented by how much? That is important. What is the template that I have shared with you? What is the template that I have shared? The template is important, friends. So for I is equal to 1, I less than or equal to n, I is equal to I plus a, then what does it mean? How many times this loop is executed? Let's say this print loop, print statement. Can you tell me? I is 1 going till n, but I'm incrementing every time by I times, which means this is going to execute how many times? I divided by n, right? I divided by n. Am I correct? Sorry. No. N divided by a. N divided by a, right? If a is 1, n times. If a is 2, 2 times. A is 3, n by 3 times. Like that. Like that. Now see here. I is equal to I plus what is there? N is there, which means this is n, whatever n, okay, plus whatever is there, that you need to write it in the denominator, so that number of times, how many times it will execute, n will cancel 1. So this print loop only executed 1 time. Therefore, time complexity is constant, order of 1. Very tricky questions I have placed here. I know you people will by heart and you will say the answer. I know you people will by heart and you say the answer, but lot of tricky questions I had kept. Without applying your brain, you can't get the correct answers, friends. Okay, I have invested lot of time in creating these questions. Okay, na? So please show some respect to my creativity. Okay, just like that, if you get the answer, that will be wrong. Very few people give an answer as 1. Remaining all people give an answer as n. Right? So from now onwards, take pen and paper and analyze and tell me the answer. Now everyone please type +1 if you understood this. Okay. Right? Okay, good. Okay, now from next question onwards, don't do the mistake. Next question onwards, please don't do the mistake. Okay, third question. So second question, answer is order of 1. Third question. Now some questions might be tough, I can understand, but you try. Okay. Okay, this nested loop, I will tell you one example. After that, you can try. First example. Now see this, friends. I think this is a well-known standard example. When you have two loops, you need to check two things, friends. Is it dependent or not dependent? You need to check. Whenever if you have a nested loop, whenever you have a nested loop means loop inside a loop. You need to check two things. Okay, this is easy example. Everyone saying order of n square. Okay, wait. Later slides, I kept the difficult questions. So in the nested loop, you check dependency, no dependency. Dependency, no dependency. Okay. So, sir, what is this dependency? Okay, let me tell you, friends. It's a simple concept only. This is. Okay. So this is the nested loop. I'll give you an example for both of them. I'll take this code. Same code. This is the original problem. Okay. I'll put it here. You'll find the example easy. Now. Now I'll explain what is dependency and what is no dependency. So no dependency will be very easy. These between loops, dependency or no dependency between loops. Between loops. Okay, na? Now see here. See this is nothing but I loop. This is nothing but a I loop. I is equal to 1, I less than or equal to 1, I plus plus. So this is nothing but a J loop because J is a variable that I have used here. Now see inside this J loop, are we using I? Anywhere here. Okay, anywhere here. Does it affecting these I value? Does it affecting this J loop? No, not affecting. This is also running n times. This is also running n times. So this is called as no dependency. Happily, you can execute. This loop is for n times. This also for n times. Nested loop, you have to multiply. So n into n, this is order of n square. Whereas if you see, this is I loop and this is J loop. Now, how many times you need to run this J loop? It is depending on the outer side loop variable. Therefore, this is called as a dependency. Hope this is clear. Got it now, friends? What is meant by dependency? This is called as dependency. And now, if it is a dependency, how to solve? Okay, that is little tough. How to solve? If dependency is there, how to solve? First of all, I hope you understood the difference. You please, everyone understood at least the difference between dependency and no dependency. Okay, very good. Okay, first we will see a few problems on no dependency. Then I will come to the dependency problems. Okay, first we will see a few questions on the no dependency. Because in no dependency also, I have added some tricks. You will make mistakes. Okay, so next slide, I'll have new question. Please be ready. Don't do any mistake. Okay. Okay, this is order of n square. Easy question. This is okay. Next slide. Fourth question. Now tell me. Please be careful. Okay. Please be careful and answer. Okay. Few students are giving correct answers. First think, friends. Okay. Just like that, please don't solve. Finally, I want answer in order of. Finally, I am expecting answer in big O. Big O. Take time, no problem. I can wait. No problem. I can wait. I want to fulfill my promise. That is, without seeing the code, you need to tell at the end of the class. That is what I'm expecting from you. And it will happen. Don't worry. So many problems I had kept. Okay. Somebody is saying order of one as one answer. Okay. I'm just writing whatever the answers that you are typing. Somebody is saying order of n into log n. This is also another answer I'm getting. And order of n square also I am getting. Okay. Then I think these three answers only I'm seeing. Either n log n, r1 or n square. See, if it is 2n, 2 you can ignore, friends. If it is 2n, you can ignore this 2 and you can write it as order of n. Okay. Constants you can ignore. Okay. Now I'll start the explanation. Just see, observe this, friends. Blindly don't write the answer. Just to first given a code, try to observe and analyze. Then you can tell the answer. Always remember. Just like that, please don't say the answer. Okay. See, this is I loop. This is I loop. And this is J loop. Okay. First of all, dependency or no dependency? No dependency. Correct? Because this is I loop. Are we using anywhere inside these conditions? No, you are not using. So clearly this comes under type 2, no dependency. If it is no dependency, it's very easy, friends. See how many times this loop is running. See how many times this loop is running. You simply multiply and you put it inside that big board. Okay. How many times this loop is running? Starting from 1, going till n, and every time you are incrementing by plus 1. So this loop is running n times. Okay. If this loop is running n times, inside whatever the value you multiply, then definitely value will be more than n. N or more than n. So order of 1, is it possible? Answer. Tell me. Order of n, any possibility to get the order of n as answer? Never. Because this itself is taking n and you need to multiply with some value here. So then definitely answer will be n or bigger than n. So order of 1 is no chance at all. No chance at all. Okay. Okay. Now, when order of n log n will be the answer, if this loop is running log n times, then I can say order of n into log n as the answer. For example, let me check. How many times this loop is running? Now here the beauty is, so j value is starting at n by 2. Remember, j value is starting at n by 2. Okay. One time you are printing. Okay. One time you are printing. Next time what will happen? J value, I am incrementing by plus n by 2, which means n by 2. Next time I am adding another n by 2. So n by 2, then what it will be? It is n, right? So is this condition true or false? J, true, because n is less than or equal to n, which means one more star it will be printed. After that, if you add another n by 2, after that, if you add another n by 2, this is going to become 3n by 2, which means 1.5 into n. Now tell me, is this condition true or false? No, it is false, definitely. Right, because 1.5n is less than or equal to n. This is false, right? This is false. Now, can you help me? How many times my J loop is running? How many times my J loop is running? 2 times only. J loop is running only 2 times. Only 2 times. So how many times outer loop is running and how many times inner loop is running? You need to multiply. So n into 2, which is 2n. If you want to put this in terms of big O, I told you cancel common constants and you can put it here, simple. So order of n. So order of n log n is also wrong. Order of n square is also wrong. Correct answer is order of n. So you got it? Everyone got it, friends? What is the mistakes that you are doing? So as I mentioned, I have invested a lot of time in creating questions where students will make mistakes so that they will learn. Next time they don't repeat these mistakes. Okay, good. So the answer is order of n. Order of n. Okay, analyze, friends. Analyze. I can't much emphasize on that. Analyze. Okay, fifth question. Now come on. I know again you will people do mistakes. You please tell, I'll write the answers here. Take time. Take time and understand what is happening and tell me. Okay, I'm getting some answers. I'm writing here. Order of n square is one answer I'm getting. Another order of n cube I'm getting. Order of n also one answer I'm getting. Somebody saying order of one also. Okay. Order of n power 3 by 4. Okay. Okay, n cube I have already written. Okay, I think very good. First of all, you are trying, friends. I want to appreciate for that. So I think among all the batches that I have taken, like your batch is excellent. Everyone is responding. I mean, I'm liking that. Because this time complexity I have explained more than 29 times. I have explained because in Masai so far I have covered 29 batches. The time when I joined Masai, 29 batches were over. This topic I have thought in your batch, like everyone is, I mean, giving the answers. That is like very good. Okay, now see the solution, friends. Now see, first of all, is it dependency or no dependency? This is I loop, okay, and this is J loop, and this is K loop. K loop, okay. No dependency because see, are we using anywhere? Now tell me, friends, in place of n, if I replace I, can I call this as a dependency? If I replace I there, can I call this dependency? Yes, very good. In place of n, if I replace j, can I call this as a dependency? Yes, because this loop is present inner here. Therefore, either among I or j, anyone if you replace, then you can call that as a dependency. Okay, very good. So this is no dependency. If no dependency, then your life is very easy. If no dependency, life will be very easy. See every time how many times loop is running. This loop is running how many times? Here, n times. Okay. This is running how many times? Approximately n by 4 times. See, starting at 1, going till n by 4. So n by 4 times approximately. Now see the beauty here. How many times this loop is running? This is the catch. K is equal to 1. You are printing and immediately you have written the break statement. So what does it mean? Whenever if you write the break statement, whichever the loop this break is associated, that loop will fail. Now this break will fail this loop? No. See, in whichever loop you have written that break statement, only that loop will break. Remaining things will execute as usual. Okay, na? So therefore, how many times this loop is running, friends? Only one time. Only one time. Okay, this is running n times. This is running n by 4 times. And this is running one time. So if it is a nested loop, you can multiply. This is running n times into this is running n by 4 times. This is running one time. So which is nothing but n square by 4, which means 1 by 4 into n square. So whatever the constant, this you can ignore when you're writing the big O. You can ignore this constant and you can write inside this big O order of n square. Got it? Therefore, so order of n square is the answer. Order of n square is the answer. Order of 1, no way. No way. Okay. Order of n also, no way. But n cube, okay, right now I don't want to say. So order of n cube is the answer. I hope it is clear. How? Okay. So what mistakes you are doing, please rectify. Okay. So the answer is order of n square. Yes, answer is order of n square. No dependency. Okay, let's enter the dependency. Now the interesting things will start. So before that, we'll take a small break. Next, all questions are dependency only. After whatever questions, they all are dependency. And they're really interesting questions. So we'll take a small break. We'll take a small break, friends. So time is now 8:08. Tell me when we will meet again. Now it is 8:08. So when we will meet, how much time break you want? 8:15, huh? 8:10 only. Yeah. Then that is not called as a break. Okay. So let's take 10 minutes. 8:15 we will meet. So we'll meet at 8:15. So please come back. Things will be much more interesting. So let me pause the recording for some time. Okay. Now from now onwards, the new type will start, friends. That is dependency model. Okay. See, no dependency will be very easy. Just by seeing itself, we can say the answer. But dependency is not like that. We should be very careful while solving. Okay. Let me tell you dependency problems. Please see everyone. Please see everyone here how I am solving this. Okay. First of all, this is I loop and this is J loop. So I loop condition, which means so this loop, how many times this loop has to run, that is depending upon the value of I. So clearly this is dependency. So this is dependency. So in the dependency, simple. Okay, just assume this for loop is not there. If this for loop is not there, then can you help me? How many times this for loop will run? Just this for loop. Tell me. Assume these values are not at all there. This for loop is just, let's ignore. Okay, maybe I will write it like this. I will take this part. I'll take this part. Okay, so just to tell me how many times this for loop, concentrate only on this for loop. This is very easy. This is template 1, right? This is template 1. So how many times this for loop will run, friends? I times, right? Starting at 1, going till I, and incrementing also by +1. Therefore, this loop is also going to run I times. I times. Okay, now? So this for loop, I can now say that run for I times. Okay. But overall, how many times this needs to run, we should know. First time, I is equal to 1. I is equal to 1. Now I will be writing number of times inner loop runs. Number of times inner loop runs. Inner loop runs. Okay. So which is nothing but I times. Therefore, if I is equal to 1, it is going to run for 1 time. If it is I is equal to 2, can you tell me how many times this loop will run? 2 times. Similarly, if I is equal to 3, how many times this run? 3 times. And how long this loop is going to run? Till I is equal to n. Till I is equal to n, this loop is going to run n times. Now, total, overall, how many times everything will run? Total, you simply add them. Total, you simply add them, which is 1 plus 2 plus 3 plus and so on up to n. Right? So we know already this formula, n into n plus 1 by 2. N into n plus 1 by 2. Okay. This if you want to write it in big O, what is its representation in big O? See, highest nth degree term, that is n square. Therefore, this is order of n square. Very simple. Just the analysis, that's it. Understood? Over, friends. That answer is order of n square. Order of n square. I think you might not believe solution is over. Got it, everyone? What we have done? Dependency rocks. Okay. So far, we have seen that no dependency easy, but at the end of the class, you will tell you dependency is easy, and I will make it happen. Okay, na? Those who did not understand, I'll explain one more time, friends. Please see now. You know how many times just this for loop, how many times? I times. But Oh, just this for loop I don't want. Overall, how many times this loop is running, like, or this print is executing, I want that. So when I is equal to 1, 1 time. When I is equal to 2, 2 times. Like that, this is going to run till n. Till n it is going to run. So I is equal to n. 1 time, 2 time, 3 time. Total 1 plus 2 plus up to n, which is n into n plus 1 by 2. So order of n square. Got it now? This is whole code answer, friends. Order of n square. No, it is not order of n cube. Okay, Varun, can you unmute and tell me how did you got order of n cube?
Hello.
Yes.
Sir, in the first loop, it runs for n time.
Okay.
And to whenever we have an nested loops, we multiply the number of time first loop is running with the number of time second loop is running, right?
Yes, that is when no dependency.
So
But
in dependency, we don't have to multiply them, we have to add them. The
you
number
should
of
not
times.
multiply, you should analyze. Okay? Yeah, you can multiply also, but by after having lot of experience, you will get the correct answer. But for now, when it is a dependency, you please unroll them. Unroll.
Okay, we will take the highest of the both.
You have to unroll. Like what I mean to say is, unrolling means I is equal to 1. What is happening?
Yes, we have to give the big O to first loop or the second loop, highest value.
Outer loop. You should start with outer loop. Okay.
Okay, sir.
Outer loop. It is running n times. But okay. But I is equal to 1. What is hangama that is happening inside? That you should know. When I is equal to 1, this print is executing only once. Okay. When I is equal to 2, how many times this for loop is executing? 2 times. Which means here 1 star will be printed. Here 2 stars will be printed. What will happen when I is equal to 3 here? 3 stars will be printed. Like that, here 4 stars will be printed. Okay. So overall, if you check here, n stars will be printed. Now total how many stars is nothing but your answer. Which means those many times loop is running. Okay, na? So try to count it how much this is. Exactly this is n into n plus 1 by 2. These many stars we are getting, but we want answer in terms of big O. Whenever you want to answer in big O, see highest nth degree term. This I have told in my last class. Highest nth degree term. Highest nth degree term. So n square, therefore order of n square. Understood, Varun?
Yes.
Oh. Yeah, anyone have any other doubts, friends? Yeah, so somebody is asking, if you have n plus n square is like this, can you say this is big O of n square? Yes, obviously you can say. You have to say, because this is the highest nth degree term. Okay, to meet one boyfriend, you are taking n. To meet another boyfriend, n square time. To be on the safe side, which one will you say? N or n square? Which is bigger, that I will say. Got it? So n square. Okay. Next. So answer is order of n square. Yes. 7th question. Now the things will slowly start interesting, friends. Now please analyze it carefully. Analyze it carefully. Okay. Always remember our previous template. What is our first template? This is I is equal to 1. I is less than or equal to n. I is equal to I plus n. Okay, assume some order of one statement is present here. Okay. How many times this for loop will run? Whatever this value, okay, n times. If it is incrementing by 1, 1, by 2, 2. But this is incrementing by a. So n by a times. So based on that, try to answer. See, this is previous year gate question. This is one of the previous year gate question I have taken as it is. I didn't remember exact year, but this is one of the gate question. Okay, first of all, it is dependency or no dependency, tell me. See it carefully. See it carefully. Yes, it is dependency. Yes, it is dependency, friends. This is I loop. This is J loop. Now you may ask, sir, how it is dependency? Anywhere I can use it here. Yes, I am using here I. How many times this loop needs to be incremented depending upon this I value, which means it is dependency. Yeah, here. This is depending upon the I. Based on that also your answer will change, friends. Okay. Somebody is saying order of n square. I'm writing answers. Order of n square is one answer. Order of n log n also one answer I'm getting. No, I don't reveal the answer now. Okay, people are asking, tell me my answer is right or wrong or not. Okay. Order of n is another answer. You are not doing analyzing, friends. I mean, I'm not happy. Sir, we can see everyone chat. Okay, let me turn off that chat. Let me turn off chat to host and co-host only, right? So we can see everyone's chat. No, you cannot see now. I made it to only host and co-host only. You can't see the others chat, I think. All are direct messages. Yeah. Okay, let me explain. So, first of all, it is dependency, friends. First of all, it is dependency. Now, just to listen this, just listen this. Please listen this. Okay, I'm requesting you all, please listen. Like when you're saying answer as order of n, please try to think once. Assume this loop is not at all there. This loop is not at all there. Then time complexity will be n, friends. Everyone agree? Everyone agree with that? Okay. If you are saying answer is order of n means, if you are saying answer is order of n means, there is no use of this loop, right? Of course, then only everything will become order of 1. Then only this is n into 1, order of n is correct. But there should be some importance, right? This loop. There should be some importance will be given to this loop. Do you know that this loop is running only order of 1 time? Okay. Then n into 1, I can say order of n as the answer. No. No, no. Right? Okay. First understand this. Okay. Now, some people are saying even order of log n as the answer. Array, tell me, by any chance also this answer is possible? By any chance, this answer is possible? If this is possible means, okay, ISRO people launched the Chandrayaan 3, right? So that will immediately come back to our Earth. Whichever direction that it took, okay, immediately it will come back to the Earth. Sriharikota, wherever they launched it. If this has to become a true, how it will become? Come se come to n time to chahiye na. At least n time will be required. Maybe more than that if you give importance to this loop. So how it can become log n as the answer? Please remember this example. If this is true means, then Chandrayaan 3 immediately it will get back to the Earth, whichever route that is followed, without having any fuel. Okay. So please, okay, don't say these kind of answers, friends. Please think for some time. Please think for some time, okay, before you giving the answer. Okay. It's a badya. Please don't give the answer. That is better in the interview. Okay. Isse acha to keep calm in the interview. That is far better rather than giving the wrong answers. Totally, it will create negative impact to the interview room. Okay. Okay. Now let's see the analysis. Let's see the analysis. Okay. I will take this part outside. Just to tell me, friends, how much time this loop is running. We have this template I have provided. This template I have provided. Based on this template, can you please tell me how many times this loop is running? Yes, n by whatever this value divided by how much you are incrementing. I am incrementing by I. Correct, na? Therefore, this for loop is going to run n by I times. N by I times. Okay. Now, people are saying multiplying. Are this is dependency. You can't multiply n into n by I. You need to unroll. Whenever there is a dependency, you need to unroll. What is meaning of unroll? Unroll, you need to unroll, which means what is happening I is equal to 1, what is happening I is equal to 2, what is happening I equal to 3. Like that, you need to unroll. This is important, friends. Please don't multiply. Okay. Let me explain what is happening. Now, see, simple. I is equal to 0. Okay, let me take I is equal to 1. How many times inner loop will execute? How many times inner loop will execute? N by 1 times. Array, how it is 1? When I is equal to 1, inner loop, how many times it will execute? N by 1 times. Very good. N by 1 times. Okay. Next, I is equal to 2. How many times inner loop will execute? N by 2 times. I is equal to 3. How many times it will execute? N by 3 times. N by 3 times. Like that, how many times outer loop will run? See, this corresponding to the outer loop. Till n times it will run. So, n by n, which is nothing but 1 time, right? N divided by n, which is 1. Okay. Now, total, if you want, try to add them all. Total you need, na? So, better add them. So, total means try to add everything, which means n plus n by 2 plus n by 3 plus and so on plus 1. Now, from this, if I take n as common, can I write this as, see carefully, if I take n as a common, 1 plus 1 by 2 plus 1 by 3 plus up to so on 1 by n. Now, if you remember, I have already explained what is this series represent. Tell me what this series represent. Big O, in terms of big O, what this series represent. In the starting of the class, I told. There is somebody saying n. I think I need to do suicide. Okay, bye bye. I'm going to do suicide. Okay. Shall I go? How it is n, right? I told right. I told n right already. This is n, log n. This is log n. N into log n. Now, what is the overall time complexity? Order of n log n. Order of n log n. I think only few students given this correct answer. It's okay, friends, if you are not able to give the correct answer, but at least now you are learning, right? That is important. Okay? Understood, everyone? Learn this, okay? I know it is okay, you can make mistakes, because first time when I was learning, I also made mistakes. But now you understand. Next time, don't repeat these mistakes. That's the only thing I want from you. Okay, so whenever there is a dependency, please don't multiply, friends. What you need to do, please everyone type. Whenever dependency, please tell me what you need to do. Everyone type. You need to do unrolling. What is meant by unrolling? What is happening at I is equal to 0? What is happening? Or I is equal to 1? What is happening? I is equal to 2? What is happening? Like that, I is equal to 3. What happening every time? And you need to add them up. Add them. That is what you have to do. Okay. So next time, next question I'm going to reveal. Please don't do the mistake. 8th question. So this question answer is order of n log n. Correct. 8th question. Okay. Now question is in front of you. At least this time I'm expecting correct answer from everyone. This time correct answer I'm expecting from everyone. Now everyone is giving correct answer now. Very good. Still some students are giving order of 1. I want to kill them. Send me your address. I'll come now to your home. People who are giving order of 1, order of login, please give your address. I will come. I'll come to your home with knife. Some sharp knife. I'll come. Please give address. Please give address. These 2 people. Whoever is giving. No. Okay, some sharp knife. I'll go to some mutton shop or chicken shop. Right, I'll take the knife and come. Okay, Satyam. Please tell me, Satyam. You raised your hand. You can speak. Yeah.
सर
Tell me.
सर ये पता कैसे चलता है सर कि निकालना कैसे है, मतलब इसका जे ग्रेटर देन इक्वल टू आई, सॉरी लेस देन इक्वल टू आई जो लिखा हुआ है, मतलब यहाँ तक तो समझ गया, फर्स्ट लाइन तो समझ जाते हैं सर।
Arre, you please slowly speak. I can't understand complete Hindi. What you are saying? Slowly.
फर्स्ट लाइन समझ गया, ठीक है सर।
Sorry.
फर्स्ट लाइन अंडरस्टैंड,
Okay.
and second line dot understand, because I know j less than equal to I, but how
Okay. I will explain this example. With this, it will be clear. Okay. You did not understand this loop, right?
सर कैसे लॉजिक लगाते हैं कि ऑर्डर ऑफ एन है, ऑर्डर पर लॉग एन है?
Acha. Okay. Okay. Just see this. See others. You please try. Okay. I'm explaining doubt to him. For example, for I is equal to 1. Okay. I less than or equal to n. I plus. Okay. So inside print, what I'm writing as maybe let's say your name, Satyam Yadav. I'm writing. Okay. Just see this. If I give n is equal to 5, how many times this Satyam Yadav will be printed? Tell me.
5 times.
5 times. Very good. If I give n is equal to 100, how many times Satyam value will be printed?
100 times.
100 times. If I give 1000,
1000 times.
1000 times, right? Okay. So whatever this n, those many times the Satyam Yadav is printing. Therefore, this loop is order of n.
Okay.
Got it?
Got it.
This much you understood, right?
Yes.
Okay. Just wait for 2 minutes. I will explain this question. You will get everything. Okay. Okay. So now I am explaining the solution. Please see everyone. Okay. As I told, I want to kill these 2 people, order of 1 and order of login. Array. Come say come this to n times will run, right? How it can be order of 1 as the answer? How it is possible? Tell me. How log n is possible? Because minimum n, if n is, I am happy somewhat, but anything less than n, I am not happy. Got it now, friends? So please don't do such mistakes. Okay. Now clearly, friends, this is dependency because this is I. Okay. And this is J. I you are using inside. So which means clearly this is dependency. Whenever there is a dependency, what I told, you need to unroll. You need to unroll. Okay. Right. First of all, just let me see what will happen inside this J loop. So inside this J loop, how many times it will run, friends? So what is the standard template that we had? The standard template that we had is for I is equal to 1, I less than or equal to n, I equal to I plus a. This is the standard template that we had. And inside I am writing some order of 1 statement. Some order of 1 statement I am writing inside. Okay, what is this answer? This is nothing but n, whatever this value, okay, divided by how much you are incrementing. This we are already know, well-known template this is. Okay, this also see how long it is going, I times divided by how much you are incrementing, that value you need to keep, that is also I. So I divided by I, which is nothing but 1, which means this loop is executing only once. Only one time only this loop is executing, friends. Okay, now if this loop is executing only one time, which means now try to unroll. Now if I try to unroll, that is I is equal to 1. See carefully. So this is outer loop. OL means outer loop. I is equal to 1. This loop executing once. Similarly, I is equal to 2 also. This loop is executing once. Executing once is nothing but one print statement is printing. That's it. Only once means one print statement is coming here. Similarly, when I is equal to 3, okay, only one time it will execute, no matter what is the I value. So 1 star it will be printed. Like that, I value goes till n, because when this inner loop will fail, right? So here, therefore, here also 1 will be printed, which means 1 star. Now, total, how many stars I am going to get it here? 1 plus 1 plus 1 up to till n. So which is nothing but n. 1 rupee, 1 rupee, 10 rupee, 10 rupee, 10 rupee, like that n into 10. Similarly, n time. So the time complexity will be order of n. Clear now, friends? Very beautiful question this is. Purely based on analysis. You no need to by heart anything. If you just know this template, that's it. Then everything is analysis. That is the beauty here. You no need to by heart. Okay. Simple analysis this is. Right. So the answer is order of n. Okay. Next question. Okay. This is homework. You please try this. This is the homework question. Answer I don't want to say. You please follow it. Homework. Maybe if at the end, if time is there, we'll come back. Now, 10th question. Now the different things are coming now. Now start solving things. You always check dependency or no dependency. No dependency means happily multiply. Dependency means unroll it. Okay. Take this question and tell me. Yeah, I think everyone is giving correct answer. Yeah, correct, friends. Answer is n log n. Okay. See, first of all, tell me dependency or no dependency. No dependency, because this is I loop and this is J loop. Are we using I anywhere inside? No, which means this is no dependency. Whenever there is a no dependency, you simply check how many times this loop is running, starting from 1 going till n times. How many times this for loop is running? J is equal to 1. You are going till n, but every time you are multiply by 2, which is a standard log n template. Correct? This is a log n base 2 template, right? If no dependency, you simply multiply. So n into log n. N into log n, which is order of n log n. Right? Okay. See, if you even unroll this also, friends, it will work. Unrolling will work. Dependency in no dependency case also. If you want, you try to check it here. Maybe this is inner loop. I is equal to 1. How many times outer loop? Sorry. Wait. Sorry. Everywhere I'm doing mistake. You're not saying here. This is inner loop. This is outer loop. Correct? This is outer loop, right? Oh, I'm sorry. Okay. This is correct here. This is inner loop and this is outer loop. Number of times inner loop. Okay. Yeah, I think. Okay, right. Homework. So friends, this is outer loop and this is inner loop. Right? When I is equal to 1, this is going to run for log n times. Similarly, I is equal to 2, how many times? Then also this is also going to run log n times. I is equal to 3 also, it is going to run for log n times. Like that, I is equal to n. Here also it will run log n times. Now, if you add everything, log n, how many such log n's are there? N log n's are there. Therefore, it's a time complexity is n into log n total. So I hope it is clear, friends. You can apply unrolling, even no dependency also, but it is not required. I hope, are you getting now? In no dependency case also, you can apply unrolling. You can apply unrolling. But it is not required. Not required, friends. You can simply multiply, but not required. You can simply multiply. Simply multiply. Okay, now? Yeah, somebody raised the hand. Yes, Amit, tell me, please.
हेलो सर।
Yes.
सर जैसे कि इसमें मतलब कि मेरे को ये समझना है कि बेस टू मतलब कि क्यों नहीं आपने लिखा इसमें, जैसे एन
लिखा है ना?
लॉग एन बेस टू पीछे बताया था ना आपने
हाँ,
प्रीवियस।
लिखा है ना, बेस टू।
अच्छा अच्छा, ठीक है ठीक, मतलब वो सर बोल नहीं रहे थे तो इसीलिए मेरे को समझ नहीं आ रहा था। ठीक है ठीक है।
ओके, या सत्यम, टेल मी ब्रो।
सर ये आपने पता कैसे किया सर कि लॉग इसमें लगेगा?
अरे पूरा कहानी शुरू में हो है ना कि प्रूव भी किया मैंने, कल कल का लेक्चर में प्रूव किया ना मैंने। व्हाई इट इज ये wait, I will show where I have proved in the last class. Have you been in the last class? Present है क्या last class में?
यस सर, प्रेजेंट तो है सर।
कहाँ है वो, मैंने प्रूव किया यार somewhere. हाँ, here I have proved also how it is login. You please go through the last class video. I have proved it. Okay. Because now so many problems we need to discuss. So I am going. Okay. Okay. So
ओवरफ्लो बता दीजिए सर इसका।
ठीक है, at the end में बताता हूँ, time permits. Otherwise, you please remember for now. Okay. Later I will tell you the proof. I will stay in the class only for you, and I'll explain and I'll leave the class. But before that, I want to finish some problems. Okay. So yeah, this is answer, friends. Order of log n is the answer. Okay. Even if no dependency also, you can unroll it, but it is not required. Okay. Okay. So answer is order of n into log n. Wait. N into log n. Okay. 11th question. Now take this. This is little bit tough compared to previous. Now solve this. Analysis you have to do, friends, in this question. This is I, this is J. So it is dependency. So dependency means compulsory you have to unroll, no other option. So dependency means compulsory you have to unroll. You have to unroll. Okay. Are after 9 o'clock, what is any session is for you? After 9 o'clock, any session? No. Huh? Okay. I can take you after some 10-15 minutes, right? Okay. Because I want to complete all these problems. So yeah. In case if you feel boring, let me know. Maybe we can give some break if you want, or else you can finish. Big. Video on. Then please don't drop. Okay, interesting things are coming in the next slides, so please don't drop. Stay till the end. Interesting things are coming up. Okay. I can listen you for whole night. Okay, you stay till whole night. I'll teach some other things. Those who want to stay till night, you can stay. Okay, I'll teach something else. Yeah. So let me start. Can I start the explanation, or you need some time? Okay. See friends. So this is inner loop, na? So since clearly it is a dependency, now see, every time same process, okay. This is a, okay, somewhat interesting here. Let me write this. First of all, what is the standard template that is there for here? For I is equal to 1, I less than or equal to n, okay, I is equal to I into 2. I is equal to I into 2, and let's say some constant things are present here, order of 1. So what is the time complexity for this? The time complexity for this is order of, okay, log n. This is the well-known template. Order of log n base 2. This we are already know, friends. A standard log n template. Okay. Starting at 1, going till not n, going till I, and every time you are multiply by 2. So how many times this loop will run, friends? Simple. In place of n, we are having I. That's the only difference. So this is going to run order of log I base 2. So is this clear? Now things will become very easy. Now things will become very easy. This is going to run log I base 2. Okay. Now see, try to unroll this. Simple. I is equal to 0. I is equal to 1. What will happen in the inner loop? Inner loop. This is going to run log 1 base 2. Okay. I is equal, no, don't calculate now. Just wait till the end. I is equal to 2. What is happening? Log 2 base 2. Okay. I is equal to 3. What is happening? Log 3 base 2. Okay, now like that you go till n. I is equal to n. What is happening? This log n base 2. Log n base 2. Now try to add everything. So total, if you see, this is nothing but log 1 base 2 plus log 2 base 2 plus log 3 base 2 and so on, log n base 2. Now can you remember any logarithm property here? Yes, I think one property that I have discussed, that is log m base 2 plus log n base 2. This I can write it as log m into n. I can write now. Log m into n I can write, right? Okay. Now here also, see here, no, not exchange base, friends. Okay, so log base 2 inside, can I write 1 into 2 into 3 up to so on n? Can I write like this? Very good. So this is nothing but log base 2 n factorial. Can I write like this? Can I write like this? Now you want to find out this value. What is this value? So to get this answer, I want to explain a small concept, friends. The small concept is, I want to discuss two things. One is n power n versus n factorial. Okay. N power n versus n factorial. I want to discuss this. Okay. Normally tell me which one is bigger. N power n is first one. N factorial is second one. Which is bigger, friends? 1 or 2? Obviously, first one is bigger, right? So clearly, n power n is bigger compared to n factorial. Okay, now? Because see, this n factorial is nothing but n into n minus 1 into n minus 2 up to till 1. What about n power n? N power n is nothing but every time you are multiplying by n. Okay, n only. So definitely this is bigger. But if you apply log to both of them, let me apply log to both of them, friends. So this is n power n and this is n factorial. If I apply, so even though initially they were very large, okay, let me write like this. So n factorial is here and n power n is here. Okay, they are very large. They are very large. Okay, because n power n is very big, friends. Now let's apply log. If you apply log, this is nothing but log to n factorial. This is log to n power n. Now from the properties, this I can write it as n into log n. Okay, this is log of n factorial. So after applying the logarithm, okay, so it is proven that they both will become almost equal. After applying the logarithm, friends, they are going to become almost equal. May not exactly, but after applying the logarithm, they are going to become almost equal. Before applying the log, they are very far. Okay, n factorial is very much small compared to n power n. But after applying the log, after applying the log, after applying log, okay, so they are become very much closer. Therefore, wherever log n factorial base 2, okay, so this we can write it as order of n into log n. See, this proof is not required, friends. So a lot of mathematics are involved to prove this, but just to remember that, okay, see, proof is not required. If you want, you can Google the proof, but proof is not required. Okay, so just remember that for n factorial, if you apply the log, it will become n log n. Okay, now it's already proven. If you are interested, you can refer the proof. If you refer the proof, so therefore, so what we can write, friends, log to n factorial. This we can write it as order of n log n. Okay, now just remember this point, order of n log n. So the proof, if you want, you can Google this, but not required for the proof. Just remember this point. Okay, I think this might be the one thing that I'm telling you to remember. So proof, if you want, you can refer, but not required. No one going to ask. Okay. Yeah. Answer is n into log n. Yes. Now, 12th question. Now take this question, friends. Take this 12th question. I think this we have discussed already. Correct, right? We have discussed this question already. So this we have already discussed. Already. So please refer the solution. Wait. 1 minute. No. I think we haven't discussed this. Solve this question and tell me what is the answer. This is little different. One minute. Okay, tell me what is the answer. It's okay if you discussed also. What is the answer for this? Order of n, order of n square. What is the answer for this? N square, right? Answer is this is I, this is J. Okay, I think this is dependency. Dependency means unrolling is required. Unrolling is required. So just to see how many times this loop is running, only this loop I times. Only this loop is running I times. Okay. Now see, I is equal to 1. What is happening? I think we have seen this question. Yes. I is equal to 2 times. Like that, n times. Now add everything. So 1 plus 2 plus n, which is equal to order of n square. Okay, I want to give a different question. Just a minute. Order of n square. Okay, I think this is different. Let me delete this. Okay, 13 question. This question. Yeah, this one I want to take. Now solve this question, friends. This is I want to take actually. See, this is I square, okay? I power 2. This is. Sir, I can unroll but can't add and mention runtime clearly. Okay, don't worry. Don't worry. Some mathematics are involved here. But yeah, actually, this is very hard level, friends. I mean, just for the sake only I'm giving. These you will never encounter in your DSA. But just I'm giving as an extra information. Maybe in interviews they can give you. So that is why I'm saying. But generally DSA, you won't face these kind of questions. Okay. See. So clear, this is I loop and this is J loop. So clearly there is a dependency, friends. So dependency is present. So whenever there is a dependency, so try to unroll. Whenever there is a dependency, try to unroll. Okay. But before unrolling, can you please help me? How many times this loop is running? Just by using standard template. Please help me. I square, right? Very good. So this loop is running I square times. Very good. Now, so now try to unroll. It's very easy. I is equal to 1. I is now little max are involved. Please concentrate here. I is equal to 1. Okay. This is going to run for 1 square. Okay. So this is inner loop, and this is outer loop. Similarly, I is equal to 2. Okay. How many times this is going to run? 2 square. Yes. Okay. I is equal to 3. How? Sorry. Here I is equal to I into 2, right? So this is correct. So this is 1, 2 power 1. Now here I is equal to 2 square. I think you might be mistaken. So, okay, so here I is equal to I into 2, which means this is 2 square. Okay, if it is 2 square, how many times this will run? Please help me here now. This will change. I think you have done mistake here, maybe. 2 square whole square, right? 2 square whole square. Am I correct? Next time, I value is going to become 2 cube. Then how much time this will run? 2 cube whole square. Simple. Whatever that square you need to write. Like that, how long it will go? Like that, how long it will go? Maybe I will assume it can go for 2 power k times. Okay. But whenever if this 2 power k becomes n, then loop will stop. Am I correct, friends? Am I correct? Whenever this 2 power k becomes n, loop will stop. I don't know. Assume k times it is running. Assume k times it is running. K times it is running. And what exactly k value? Let's not worry. K times. But whenever if this value becomes n, then loop will start. By the time when this value becomes n, can you help me? What is this? 2 power k whole square. 2 power k whole square, correct? Okay. Now from this, can I make it? Now listen carefully. I'm changing the color. So 2 power k is equal to n. Obviously that is true. From this, what is k? This I have told last class. Apply log 2 on the both sides. Then don't you think k is equal to nothing but log n? Correct now? Okay. Now try to add everything. Now try to add everything, friends. Now if I add everything, see what I'm going to get it here. So which is nothing but 1 square plus 2 square plus 2 power, okay, 2 power 4, I can write this as, this I can write it as 2 power 6. Then after that, we are going to, okay, wait. Are we doing any mistake? Correct. 2 power 6 and so on. This is going to become 2 power k. 2 power k. Or you can write 2 power k also. 2 power k, 2 power k, friends. Now I want to find out what is this value. What is this value? Can you help me? Are you finding any series? Is it in AP or is it in GP or something like that? What you are finding out here? 2 square, 2 power 4, 2 power 6, and so on. Don't you think this is GP, friends? Increasing GP? This is nothing but increasing GP. Okay. This is nothing but increasing GP. If it is a increasing GP, then what I told inside big O, whatever the last term that you can keep inside, whatever the last term that you can keep inside. Got it now? So this is 2 power k whole square. Let me leave 2 power k whole square only. Let me leave this 2 power k whole square only. Okay, na? We already know what is the value of 2 power k. We already know 2 power k is equal to n. Therefore, this is nothing but n square over story. Order of n square. Clear? I think this might be little difficult, but try to understand, friends. I think you don't even feel, yeah, this is the answer. Somebody is saying that, wow, oh my God. Well, this is the solution. Gajab tha. Thank you. Gajab question hai. Good question this is. It's a very good question, friends. Good question. Thank you for all your comments. Okay. Good. I also feel really good question. Okay. Dimag khol diya. I could have cleared IIT JEE if I had got you in my early of 20s. At least now I got right. At least now I got it. Sir, really you deserve name DSC Anna because of your way of teaching. Thank you so much for your comments. Thank you. Okay. Loved this question, right, everyone? Thank you for all the comments. Okay, somebody say, yeah, Nitish, tell me what is the doubt?
हेलो सर
हाँ, yes, Nitish. हाँ,
सर आपने ओ एन स्क्वायर निकाला बट ये तो सेकेंड लूप का ना टाइम कॉम्प्लेक्सिटी हो गया सर
correct. This is this loop time complexity. Yes.
ओके सर लाइक मुझे लगा ये पूरे
नहीं,
लूप का है
बस ये लूप का है ये टाइम complexity.
ओके
Okay.
सो लाइक मतलब जो पहले वाले के को आपने लॉग इन माना है तो मल्टीप्लाई हो जाएगा सिंपली से आई थिंक
हाँ, ये तो लॉग इन है.
ओके सर डाउट था लगा कि पूरे का आपने नहीं बता रहे हो इसलिए
No, not like that. Okay. Yeah. So let's see the next question, friends. So answer for this is order of n square. Yes. Order of n square is correct. Okay, this is good question. I think we have only 3 more questions left. The last solution video I will watch daily. It was really funny. Thank you. सर आप बहुत अच्छा समझ रहे हैं सर. मैं बायोलॉजी से हूँ तो थोड़ा दिक्कत. Yeah, this is also good question, friends. So try to solve. So try to break the problem so that things will become more simple. Rather than seeing all at a time, try to break the things so that easily you can construct the solution. Yeah, later I will share the feedback form. So try to fill that also. Just want to see how is your experience and all. Yeah. Sir, please make me co-session will become as I also DLC from the students. Please make me. Okay, sure, sir. Yeah. Okay, those who are feeling confusion, don't worry, friends, because first time you are seeing, so obviously it is possible. Maybe again you listen to the class, you will become master in this. You can bet with any people outside who are good at time complexity, they can't beat you. That is my promise. Okay. Because we are we are learning concepts altogether at a different level. Okay. In fact, if you see any YouTube type, these things you'll never find. Okay. Okay, so I think I'm getting a couple of answers. Somebody saying n log n and somebody saying n log n. Okay. Okay, let me explain, friends. See carefully here. See here. This is, let's say, this is K loop. Okay. And this is I loop. Okay. And this is J loop. This is J loop. Okay. So, any dependency here? Tell me. Just observe carefully and tell me any dependency. Yeah, dependency is there. For the first time, if you see now, you might feel that there is no dependency. But if you observe carefully, dependency is there. If you observe carefully, dependency will be there. Okay. K loop is not at all depending here. Only thing is inside J, inside this block, we are using I value. Therefore, can I ignore K loop? This I can ignore. At the end, I can multiply, right? This, there is no effect on that. So I can completely take out and at the end I'll multiply with n. No problem. But the main thing is this one. The main thing is this one, friends. This block. This inside block is important for us. Okay. Yes. Let me take this to the next slide and we will see what is the time complexity. Then we will multiply that answer with n. Okay. I have just separated that. Okay. Now see here. So clearly there is a dependency. So clearly there is a dependency. Okay. Na? So first of all, okay, just observe this. Only this loop try to observe. Only this loop try to observe. How many times this loop is running, friends? Tell me. If you observe carefully, this is the standard template. Am I correct? This is a standard template, right? Which is log base 3 I times it is running. Everyone agrees with me? Right? Okay. See, in the J, you are using I value, which means ultimately in the J, I is present here. Therefore, log I base 3. One more time, I'm repeating. Inside J, you are taking I value. So, which means this J is nothing but I. Therefore, log I base 3. Now the story will be very easy. First time, I is equal to 1, outer loop. Now try to see what is happening at the inner loop. In the inner loop, okay, log 1 base 3. Okay. When I becomes next iteration, what is the value of I? Can you tell me? Next iteration, what is the value of I? It will become 3, friends. So it will become 3. Then how many times this loop is running? Log 3 base 3. Because whatever the I, those many times. After that iteration, what is the value of I? 3 square. Very good. 3 square. Then how many times this loop will run? Log 3. Okay. 3 square. After that next iteration, I value is going to become 3 power 4. Okay. Then this is log 3. Okay, 3 cube here. It is 3 cube. 3 cube. Okay. Log base 3. It is go for 3 cube. Up to so on. I don't know how many times it is running, but let me assume k times it is running. I is equal to, let's say, 3 power k times. Okay. I don't know exactly how many times it is present running. Maybe I will assume k times. K times. Okay. K times. Since it is running k times, okay. So here, how much it will run? Log base 3. So 3 power k. 3 power k. Now, when this loop will stop, tell me. Obviously, if this value becomes n, then loop will stop. So if this value approaches to n, this loop will start. So therefore, can I make it n is equal to 3 power k? Of course, you can make. No problem. Now, what is the value of k? So from this, you can get k is equal to log n base 3. We have already seen also this. Okay, now? Now try to add all these things. Now, when you add all these things, what it is going to become? Log 1 base 3. Log 1 base 3 plus log 3 base 3 plus log 3 3 square plus and so on log 3. Okay, so 3 power k. 3 power k. Now, what we can write? I think we can multiply everything, right? Where is GP? Let's no GP, right? Here. Or else we can do, wait. Maybe here. We are adding everything. Okay, this can I write like this? Something like, so see, this is 0. This is 1. This is 2. Okay, maybe something like that. See, here I will write one more term. Log base 3 cube plus log 3 power 4 up to so on log base 3 power k. Okay, now see this how I am simplifying. We know log 1, its value will be 0 plus this, can I write it as 1 into log 3 base 3? Yes, of course you can write. Plus this, can I write it as 2 into log 3 base 3? Yeah, you can write it, no problem. Plus from the properties, okay, everything depends upon these beautiful log properties only. 3 into log 3 base 3. This is 4 into, okay, log 3 base 3. Base 3. And so on. This is k into log 3 base 3. Okay, we know already log 3 base 3, its value will be 1. Its value will be 1. Correct, na? So this I can write it as. So everything will become 0 plus 1 plus 2 plus up to this is k. This is nothing but k into k plus 1 by 2, right? K into k plus 1 by 2. So which is k square? Order of k square. But what is the actual value of k? Order of k square. Okay, na? But what is actual value of k? From this, we already got log n base 3. So this answer is order of log n base 3 whole square. Log n base 3 whole square. This is only this part answer means. But what is my final answer? You should multiply with n, right? Please don't forget, friends. Outside n is there, okay? Which means this part value only we got it as from the derivation. This part answer only we are getting as log n base 3 whole square. Log n base 3 whole square. This is only this part. But outside you have n also. This loop is running for n times now. If you remember previously, we have separated this. So what is the final answer? Order of n into log n base 3 whole square. N into log n base 3 whole square. That is the final answer. Okay, now? This is the final answer, friends. Right? Okay. Yes, the answer is n into log n whole square base 3. Yes. How many questions are there? Okay, 3 more questions are there. Shall I stop or should I continue? Continue. Huh? Okay, take 5 minutes break. I mean, yeah, I thought I should be finishing. Okay, shall we take a 5 minutes break? Because it is difficult to. Yeah. Okay, no break. I will finish it in maybe next 15-20 minutes. Please, no break. Okay. Now see this, friends. See this. Yeah, I also not required the break. I am going in a flow. I'm going in a flow. First, observe the question. Okay, observe the question first. Observe, break down, solve. Things will become easy. See, this is multiplication, friends. This is not exponential. This is simple multiplication. Standard log n template. This is standard log n template. This is. Looks like dependent, but it is independent. Yes, yes. Yeah, this is also previous year gate question. This is also previous year gate question. If you give the correct answer means you can feel self-satisfaction. Yes, I am able to solve the gate question. If you give the correct answer, you can self-satisfaction, you can finish. Happily, you can take the dinner. Happily, you can take the dinner with a lot of satisfaction if you are able to solve this question. Next 2 questions also gate questions only, but most of they are giving correct answers. Order of n square is the answer. Okay, let me explain. First of all, see, this is I loop, okay, total this is I loop, and this part is only J loop. This part is only J loop. Okay, this part is J loop, and this part is K loop. Tell me, is there any dependency here? What is meant by dependency? Inner loop is running depending upon the outer loop, but here it is nothing happening. Not like that here. So clearly it is no dependency. First of all, you need to observe that. When it is no dependency, things will become bacha things. Okay. How many times this loop is running? N times. Okay. How many times this loop is running? This is a standard log n template. This is standard log n template. This is, which is log n base 2. How many times this is running? This is a simple standard for loop. This is a simple standard for loop. Now, if you want to put all these three things together, then you should be writing like n into, okay, you need to add, these are individual things, friends. So you have to add, then multiply with the nested one. Always remember. So just a standard thing that I want to explain here. If you have loop L1 like this, L1 is one loop. Inside this loop L1, if we have two loops, let's say this is L2, okay, this is L2 loops, and let's say this is L3. This is L3. Like whenever if you see these kind of situation, assume this is running, let's say N1 times, this is running N2 times, this is running N3 times. Whenever if you see these kind of pattern, what you should do, you have to write N1 into N2 plus N3. N2 plus N3. Okay, na? Okay. You know, whenever if this is the plus, you take whichever is the maximum. Maximum of N2 comma N3 you take, and that you multiply with N1, and that is the final answer. Okay, na? Similarly, here also, if you check here, N into, now see answer to this question. N into, you have to add these two because these are not nested. These are individuals. So this is log n base 2 plus this is n. Now among n and log n, which is bigger, friends? Yes, n is bigger. I hope now you can find the importance of the yesterday's class. Now you can find the importance of yesterday's class. See how I am connecting the dots. Whatever the prerequisites are there that I am already teaching. And then I'm coming to this main point. Right? This is n because this n is maximum and into n. So n square. So finally, the time complexity will be order of n square. So whoever given the answer as order of n square, you can feel double, triple, 4 times or x times happy, infinite times happy. You are able to solve the gate question. Okay. See what standard you are studying, or are you belongs to tech background, non-tech background, BS, whatever, but you are able to give correct answer to the gate exam question. Okay. So believe in the stuff, friends. Gate is simple thing there. Okay. You can able to solve all kind of standard type of questions. Okay. So answer is order of n square. Okay. This you can take this question as homework. You can take again. This also previous year gate question only. But this is interesting question, friends. This is interesting question. Answer. Try to answer. Very beautiful question. This is. If I explain answer to this question, you will type wow in the chat. If I explain solution, you will feel wow in the chat. Answer this question. So this is the function, and to this function I am passing an array as well as size of the input. N is size of the array. Answer. This symbol is logical AND operator. Yes. This symbol is logical AND operator. Okay, I will write it separately. Logical AND operator. So I think you know the table, right? So A, B, A logical and so both are true. This can true false. This can false true, false. If both are true, then only this will become true. In all the cases, it will become false. This is the table for. This is the table. Okay. Yeah. Little trick is there in this question. Little trick is there. And be ready to type this. Without knowing array element, how can I find the time complexity? Very good question. Very good question. Without knowing the array elements, how should I find the time complexity? I will tell you. How time complexity can be find. I don't know array elements. I told you take some random elements. I told you take some random elements, some random order you take. Maybe consider an array of n positive integers, n positive random integers. Array of any n positive integers in random order, increasing order, take it order, decreasing order, any order you take, no problem. Any order you take, no problem. Okay. Please unmute. Yeah. Tell me, can I start the solution or you need some time? Okay, I will wait some time. Dependency, no dependency here. Tell me first of all. Okay, I will close it in next 5 minutes. So it will over, friends. I'll close it in next 5 minutes. This is the last question. Yeah, clearly it is a dependency. Yes, very good. Very good. Depending upon array element. Yes. Okay, let me explain the solution. Please, everyone see here. Those who have saying order of n square as the answer, please see here. Please see here. Okay, I can take some random array. So I'll be taking some random array elements. 1, 1, 2, 3, 4, 5. So n is equal to 5. So indices are starting from 0. Now, can you tell me, friends, I want to find out, like I want to run this loop as many times as possible. In such case, can you tell me what type of input should I supposed to take? Like every time I want to make this condition to be true. Then what kind of order should I take these 5 elements? In the increasing order, right? Sorted order, right? Very good. So which means I'll take all these elements in the increasing order. So that maximum number of times I will try to run. Then only I'll get the maximum worst case time complexity now. Okay, now see here carefully. So I is equal to 0, which means I is equal to 0. See what is happening. Inner loop. See what is happening in the inner loop. Okay. J is less than n. Obviously, J value will be, equal to 0. Yes. J value will be equal to 0. That is true. J obviously less than n. So this condition is true. Yes. This condition also will be true. While array of I is less compared to array of J. True, right? I is 0. 10 is less than 20 now. Yes. Which means maybe here I will write print statement just for the sake of how many times loop is running. Okay, na? If without writing also you can say like some order of n statement. That's it. Okay, now see the beauty here. Now see the beauty. Okay, I is equal to 0. Condition is true. Obviously 10 is less than 20. That is true. So 1 star will be printed. Again, this loop is true. Yes, this loop is true, friends. How long this loop will be true? J value will become 1, which means 10 is less than 30 also. Yes, so one more star will be printed. Next, J value will becomes 2. Now, array of 0 is less than array of 30. Yes, so one more star will be printed. Then J value become 3. Then also array of 10, 10 is less than 40. So true, one more star will be printed. Then J value becomes 4. Okay, then also this is right. So one more star will be printed, which means how many times when I is equal to 0, listen carefully. When I is equal to 0, how many times this loop is working? 5 times, right? Everyone agree? Next time, if this value becomes 5, when J is equal to 5, tell me, while loop will become true na false? Tell me. False, right? Okay. Okay, so here, if you can replace this with 1 also, no problem. I mean, just people who are saying 10 is compared with 10. Okay, you can replace J value with 1. Okay, so n times it will be printed, which means when I is equal to 0, okay, n times this loop is working. By the time J value, how much? 5. So this condition will become false. Next, I value will becomes 1. Now see the beauty. Okay. Tell me, what is J value? 5. Does this condition, see, when this while condition will become true, if both conditions will become true, then only while loop will become true. Obviously, right? Now tell me, is this condition true or false? Second time, when I is equal to 1. True na false? Array, J value right now 5. J value right now 5. So 5 is less than 5. 5 is less than 5. Every time J value is not 1, only first time J value will be 1. After that, once if this loop is over, next time I value when becomes 1, J value 5 only. Which means how many times this loop will execute? 0 times. Just a condition you are checking. Next time I is equal to 2. How many times? Always this condition will becomes false. 0 times. I is equal to 3. That is a beauty in this question. Okay. So if you go till I is equal to n, 0 times. Now try to add everything. So total n plus 0 plus 0 plus up to 0. So this is order of n is the time complexity. Okay. That is the beauty in this question. So this statement, once if n times are over, okay, the next time onwards, this will become always false. So clear, everyone? Very, very beautiful question, friends. This is. People who typed n square now, they might be thinking that every time this is running n type. N or at least n minus 1 like that. But that is wrong. That's why purposefully I have given this question here. I know you are going to make some mistakes. So finally, what is the lesson that we have learned here? Whenever if anyone asks the time complexity, now you should pay utmost attention to the question. You have to pay utmost attention to this question, friends. Okay. Yeah. So this you can start. You can read it. So that's it, friends. We finally came to the end. So thank you. Thank you all. Done with the class. So let me stop the recording.